Entropy is a thermodynamic quantity that represents the degree of disorder or randomness in a system. It is a measure of the number of microscopic configurations or arrangements that a system can have at a macroscopic level. In thermodynamics, entropy is typically denoted by the symbol S. The concept of entropy is closely tied to the second law of thermodynamics, which states that the entropy of an isolated system tends to increase over time, leading to an overall increase in disorder. Entropy is measured in joules per Kelvin, J/K, in the International System of Units, SI. Entropy can be understood from a statistical perspective as a measure of the uncertainty or lack of information about the microstate of a system. It quantifies the multiplicity of possible ways the particles in a system can be arranged. Systems tend to evolve toward states of higher entropy, where energy becomes more evenly distributed. This is often illustrated by the example of a gas in a container. It will naturally spread out to fill the available space. Entropy changes are typically associated with irreversible processes. In a reversible process, the entropy remains constant. Absolute entropy is a measure of the entropy of a system at 0 Kelvin. The third law of thermodynamics states that the entropy of a perfect crystal at absolute zero is exactly zero. Entropy is also a concept in information theory, where it represents the amount of uncertainty or surprise associated with a random variable. This is commonly expressed in bits. In various fields, including communication and data compression, entropy is used to quantify information loss. Higher entropy implies more randomness and, consequently, less compressibility. In quantum mechanics, there is also a concept of entropy. It's related to the number of possible quantum states available to a system, and it plays a role in discussions about quantum entanglement and the nature of information in quantum systems. While these definitions may seem diverse, there is a deep connection between them. The common thread is the idea that entropy is associated with the number of possible arrangements or the degree of disorder in a system, whether it's at the macroscopic level, thermodynamics, microscopic level, statistical mechanics, informational level, information theory, or quantum level, quantum mechanics.